Good morning, all. So, I am here to discuss some problems from the topic zener diode. So, actually, we have completed the topic zener diode. Let's discuss some problem. First problem, for the circuit shown in figure, find the output voltage, the voltage drop across series resistance, and the current through zener diode. So if you remove the zener diode from here, we will get this figure. So we want to find the voltage. That is, voltage will be RL into EI by R plus RL. That is, RL is 10 into 120 by 5 plus 10. That is 80 volts. So, since the voltage across zener diode, that is 50 volts. So, this voltage is greater than the zener voltage. So the circuit is in on state. So we can represent the circuit by this figure. So first question is the output voltage. So output voltage is the zener voltage, that is equal to 50. Second question, the voltage drop across series resistance. That is, R is input voltage minus Z. We can get this through Kirchhoff voltage law. Like, you know that here 120 minus VR minus VZ equal to 0. So we want to find the VR. So VR is 120 minus VZ. That is equal to 120 minus 50, 70. Next question, the current through zener diode. So first we want to find the current through load. That is, load current is equal to IL is equal to VZ by RL. VZ is 50 and RL is 10, that is 50 5 milliampere. Then we want to find current through R. Current through R is like, we know voltage drop across R is 70. So current through R is V by R, that is equal to 70 by 5. There is 5 ohm. That is 5. That is 5 kilo ohm. That is 14 milliampere. Now we want to find the current through zener diode. So we want to apply Kirchhoff law, Thalba Fathima. So I will be load current plus zener current, that is 5 plus second question is, for the circuit shown in figure 1, find the maximum and minimum values of zener diode current. So here the first step is to determine the state of zener diode. So it is given that 80 to 120 volt. So we know from the previous question that we want to find voltage and RF by so that is 80 into, first we want to consider that voltage, that is 80, and and 5 plus 10, that is around 80 by 50, around 53.33 is the answer. So it is greater than the zener voltage, that is 50. So if the voltage is greater than the zener voltage, then it will be in on state. So we can draw the figure like this. Then the question, so now we want to find the maximum zener current and minimum zener current. So first we want to find maximum zener current. We want to find the maximum zener current. So the input voltage will be maximum. This is the condition for zener current to be maximum. So we want to find voltage across 5 kilo ohm. By applying Kirchhoff's law, we can find that 120 minus 50, that is 70. Then current through it will be 70 by 5, that will be 14. Now we want to find the load current, that is IL is equal to 50 volt by 10 kilo ohm, that is 5 milliampere. So applying the Kirchhoff's law, we can find I is equal to IL plus IZ. From here, IZ is equal to I minus IL, that is 14 minus 5, 9 milliampere. The same in previous question. Then we want to find the minimum zener current. For that, we want to consider the VI minimum. So first we want to find the voltage. Voltage across 5 kilo ohm by applying Kirchhoff's voltage law, like 80 minus 50, that is 30 volt, and current through 5 kilo ohm, that is 30 by 5, that is 6 milliampere, and load current will be current is the same, that is 5 milliampere. 50 by 10, 5 milliampere, the same itself. And we want to find the zener current. That is IZ is equal to line Kirchhoff law I minus IL. That is 6 minus 5, 1 million. So these are the maximum and minimum zener current. Moving to the next question. The load shown in figure as AZ is equal to 18 volt. The voltage across load stays as 18 volt as long as IZ is maintained between 200 mA and 2A. Find the value of series resistance R so that E0 remains 18 volt while input voltage E1 is free to vary between 22 volt to 28 volt. So we want to find the value of series resistance. So zener current will be minimum, that is 200 mA, when the input voltage is minimum. Same as in previous question. Zener current is minimum when input voltage is minimum. That is 22. Then load current stays as constant. So IL is equal to VZ by RL. That is 18 volt by 18. That is 1 ampere. Now we want to find the resistance, series resistance by applying Kirchhoff law. So here VI minus IR minus VZ is equal to 0. So R is equal to VI minus VZ by I. That is VI. Here is 22 and 18 by I is like IZ minimum. I is IZ minimum plus IM. That is 200 milliampere plus 1000. That is 4 by 1200 milliampere. We got 3.33. What's the third question? Question. If 10 volt zener diode is used to regulate the voltage across a variable load resistor, the input voltage varies between 13 volts and 16 volts. The load current varies between 10 milliampere and 85 milliampere. The minimum zener current is 15 milliampere. Calculate the value of series resistance R. So zener current will conduct minimum current when input voltage is minimum. So same procedure applying Kirchhoff law. Here we consider the minimum voltage 30 minus IR minus 10. 10 is equal to 0. So R will be 30 minus 10 by I. So 30 minus 10. I will be IZ minimum plus IL. So here Well, the zener current will be minimum if and only IL will be maximum. This is also condition. Zener current will be minimum if load current is maximum. So we want to consider this as I is equal to IZ minimum plus IL maximum. That is IZ minimum will be 15 plus IL maximum is 85 milliampere. That is 3 volt plus 100 milliampere. 30 done. Fourth question. And moving to the last question. So the question is, over what range of input voltages will the zener circuit shown in figure maintain 30 voltage across 2000 ohm load, assuming that series resistance R is equal to 200 ohm and zener current rating is 25 milliampere. So here it is mentioned that zener current rating is 25 milliampere. So first minimum, well, we want to find the minimum voltage. We need the IZ minimum. So here we want to consider the IZ minimum as 0. So IZ is equal to 0. So in this condition, IL will be I is equal to given that VZ is 30 volts, so 30 by 200 ohm, that is 15 milliampere. So we want to find the minimum input voltage by using the techniques of voltage law. We will find IZ minimum like VI minimum minus 15 into R minus 30 is 0. So we want to find VI minimum. That will be 30 plus IR, that is 15 into R. Will be 30 plus 15 into 200. That will be 33 volts. Here it is 50 is in milliampere and 200 is in volt. Now we want to find the maximum input voltage. That is when IZ is equal to 25 milliampere. So in this condition, I will be IL plus IZ, that is 15 plus 25, 40. So we want to find the maximum input voltage. So that will be 30 VI maximum minus 40 into 200 minus 30 is equal to 0 by Kirchhoff voltage law. So you want to find VI maximum. That will be 30 plus 40 into 200. 40 milliampere plus 200 is 70 plus 8, 28. So the input voltage